All right. So you made it through section 1.1, which has got to be a relief. Section 1.2 is really just a continuation of section 1.1. When I started writing the material last fall, this section 1.1 was actually part of section 1.2 was actually part of section 1.1, and that just kind of started getting ridiculously long. Section 1.1 did, not that it wasn't ridiculously long already, but then I just kind of looked for a natural breaking point, and I separated section 1.1 into two sections, 1.1 and 1.2. So this stuff is going to feel a lot the same as section 1.1. There's not going to be a lot of algebra in here, this section, and there's just boatloads of definitions and words, and chapter 1's kind of really heavy that way, where you just get lots and lots of terminology. I'm never going to ask definitions on a test. You know, the things that you're going to need to be able to do when it comes to the test are problems like the problems that I do throughout the lecture. But it's kind of hard to do the problems in this section. You know, well, it's not hard for me to do the problems, but I think it makes a little more sense if I do the introduction to the words and definitions, just to kind of get you, maybe closer to the same page that I'm on with this stuff. So we're continuing with the discussion on sets, and in this section we start off learning 3 different ways to describe or define a set. And sets can be defined with words, using set builder notation, and if you just came out of intermediate algebra, we'll get to it in a little bit, but set builder notation is this kind of notation. And we'll get to that in a couple pages, and we'll make you remember it, the best we can. And then roster form, and I'll talk about what each is in detail, do the problems that you need to do kind of as we go through the section. So word description is probably the most basic way to define a set. It's just using words to define or describe the elements of a set. And the thing about word descriptions is there's a heck of a lot of correct word descriptions. If somebody asks you to create a word description for a set, as long as somebody that reads mathematics could read your word definition and produce the elements in the set that you're describing, your definition is fine. So when we go through the homework, when we're asked to write a word description of a set, your answers could look pretty remarkably different than mine, but yet still be correct. So in the last section, we talked about natural numbers for a second, and a lot of the problems where I ask you to write a word description of a set, it gives a set that has natural numbers in it. So just in case you've already forgotten, or if it just didn't sink in the first time, natural numbers are a set that we use a lot in chapter 1, but after chapter 1 they won't come up again. And natural numbers are just kind of positive numbers without fractions or decimals. So the natural numbers is usually described as the set n, and it has the numbers 1, 2, 3, 4, 5, and so on. So I've described the set of natural numbers here using one of the 3 ways to define a set. I defined it using roster form. And again, we'll get more into roster form when we get deeper into this section. But since I used it, I felt like saying what it was. Roster form is just listing all the elements in the set. Notice that this set goes on forever, and I couldn't possibly write every natural number. So I just put the 3 dots, and means the pattern continues. All right. So, word description is just a sentence or a group of words that describe the elements of the set. So if I give you a set that has the numbers 1, 2, 3, 4, and 5 and ask you to write a word description, so that somebody that reads mathematics would understand what the elements of the set are, you have lots of flexibility. I brought up that the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 were natural numbers because I knew I was going to use them in this example, and they're going to come up a lot in the homework. So when I look at this set A, if somebody asked me to write a word description for this set, immediately when I look at the numbers, I know these are all natural numbers. 1, 2, 3, 4, and 5 are all natural numbers. So that might be a nice word to use in my word description, because somebody that reads mathematics and understands that natural numbers are the numbers from 1 kind of to infinity without fractions or decimals would like to see that word probably. So now I need to, if I just said set A is a set of natural numbers, well, that would include the numbers 6, 7, 8, 9, 10, way too many numbers. So I'm talking over a leaf blower right now. Hopefully you can hear me just fine, not the leaf blower. So I knew I wanted to include the words A as a set of natural numbers, and now I needed to include some words to limit the natural numbers to the numbers between 1 and 5. And I use this as one such, one way to describe this, because when I said the set of natural numbers between 1 and 5 inclusive, it means it includes the first and the last number mentioned. So it's natural numbers between 1 and 5. The natural numbers between 1 and 5 are 2, 3, and 4. And the word inclusive means it includes the 1 and the 5. So somebody that reads mathematics would know that if I write the set of natural numbers between 1 and 5 inclusive, that I'm only counting natural numbers and I'm counting the first and the last number. And this, to somebody that reads mathematics well, and hopefully you by the end of this section, would represent the numbers 1, 2, 3, 4, and 5. So this would be all I need to do to write a word description for the set A, the numbers 1, 2, 3, 4, and 5. But that's not the only way to write it, and I wrote a second answer that also is another way to describe in words the set containing the numbers 1, 2, 3, 4, and 5, and it's completely different, but it means the same thing. And if you were, working ahead, you might have come up with something even completely different than I did, yet a third or a fourth answer. So anything that is equivalent to, in words, to the numbers 1, 2, 3, 4, and 5 would be fine. And so my second attempt at an answer to this, again, I just used the word natural numbers in my problem, because when I put the word natural numbers in, that means that I can't have fractions nor decimals in the problem. And when I look at in my set, and there aren't any fractions or decimals, so natural numbers felt good to say. And natural numbers less than 6, and if I look at my set of natural numbers, the set of natural numbers are 1, 2, 3, 4, 5, 6, 7, 8. They go on forever. The natural numbers less than 6 are anything less than 6 but not equal to 6, and they're the numbers 1, 2, 3, 4, and 5. So that's another correct answer for writing a word description for the set A, 1, 2, 3, 4, and 5. I don't have it on this handout, but I could even write another one that would be completely fine. So I could write answer 3, A, because it's set A, is the set. And it's kind of hard for me to think of a nice answer that doesn't have the word natural numbers in it, just because that throws out the fractions, negative numbers, and the decimals. Another thing that I might say, I like the less than. When I said less than 6, that means I don't include the 6, but I include the first natural number less than 6. If I would have said less than or equal to, I could get the right answer if I put the 5 instead of the 6, because natural numbers less than or equal to 5, it includes the 5 because it says are equal to, and any number that's a natural number that's less than 5, so it would count the numbers 1, 2, 3, 4, and 5. So there are tons of correct answers, and a lot of times for students this is the worst kind of problem, because it's so much nicer when there's only one correct answer and it's just either right or it's wrong. Here, there isn't a definitively correct answer. Any answer that I can read and understand that it's defined, only counts the elements that are in the defined set is correct. All right, another example. So I want to write the set A again. If usually we define sets with capital letter names, and if there isn't a fantastic reason to give a set another name, I like the set to call my set A, just because it's common to do. So when I look at this set A, if I didn't look at my answers, again, these are natural numbers. So Probably in my description of set A, I'm going to say A is some group or set of natural numbers. And now I need to write something more to tell me I only want the numbers that are 4 or larger. And I wrote this a couple different ways, and again, there are probably more than 2 ways to write the answer, but these are the 2 that came up in my mind when I was typing this. So this would be completely correct. Again, I put A as a set of natural numbers because the numbers in the set, there are no negative numbers, there's no fractions, there's no decimals, so those are just lovely natural numbers. And then the numbers in the last one were 5 or less. Here they're 4 or bigger. So in my explanation, I'm probably going to use the word greater than as opposed to less than, because in the last problem the numbers were 5 or less. I could say it's 1 or greater, but the nice thing about natural numbers going backwards, there's an end. One's the edge of this list. So I'm probably going to use the words greater in my descriptions because the numbers are 4 or bigger. There's no right end number, so I couldn't pin something on the right end and say it's less than the right edge. So I probably won't use a less than. And it probably wouldn't make sense to use an answer like I did for number 1 of the last problem when I used the word inclusive, because to use the word inclusive, I probably need to have a first number in the set and a last number in the set that I could grab onto. And in this set, I see the first number, but there is no last number. The set goes on to infinity. So attempting to use between 4 and some number inclusive wouldn't work so well because I don't know the right edge of this. Using a less than or equal to probably wouldn't make sense in this because, again, I don't have a right edge to tag onto. But so in this problem, both my definitions use the words greater than, and in the first one I said greater than or equal to 4 because any number that's a natural number and it's greater than or equal to 4, the or equal to tells me it starts at 4, and then greater than means I need to go bigger than 4, and then bigger than 4 but only counting natural numbers. The next natural number bigger than 4 is 5, after that 6, 7, and so forth. So that would be a completely good description of the set A because it simplifies to the numbers 4, 5, 6, 7, 8, 9 all the way up to infinity. The other suggestion that I came up with was A would be the set of natural numbers greater than 3, because if I look at my natural numbers, 1, 2, 3, 4, 5, 6, 7, and they go on forever, greater than 3, because it doesn't have the or equal to part, I'm not including the 3, and I'm only including the natural numbers greater than 3. And so it's counting 4, 5, 6, and 7. So it's exactly the same set described slightly differently. I have the word greater than 3 as opposed to greater than or equal to 4. They're both correct. They both produce, if you wrote down the elements in the set that's being described, they both give you the numbers 4, 5, 6, and 7. All right, let me keep going. Now we're going to get into some homework, and I think the ultimate best thing you could do while I'm doing the homework is to do your homework. So I tried to, for every problem in this section, and mostly for the whole semester, I tried to write even and odd problems on the same page, because when I wrote the material, I kind of made the problems in pairs so that when I do an even problem in a video, you should be able to do the corresponding odd problem to see, just to get your homework done and to have something to kind of check on as you're doing your homework. Once I do problem 2, you can watch me do problem 2. You should pause the video and try problem 1, and then go and check the answers. In the very last page of this section, there's a set of answers, and I have answers for all the odd numbered homework problems. The only thing about the first group of problems, the homework problems between 1 and 8, you could have a correct answer that looks different than mine because there's multiple correct answers. So when you're doing problems 1, 3, and 5, if you go to check your answer and it doesn't have the exact same words as my answer, that's not a bad thing. It just means you picked a different voicing of the answer, and that's completely okay. All right, so I'm going to do problem 2, and again, these 4, 5, and 6 are natural numbers, so I'm going to say for problem 2, B is the set of natural numbers so for most of these problems, I'm stuck using the words natural numbers somewheres in my word description. And then I need to write something more to tell me it's the numbers 4, 5, 6, 7, 8, 9 through infinity. This just feels like the last example. In fact, it really is the last example, other than I wrote less numbers in the set. This set 4, 5, 6, 7 dot 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 is no different than the set 4, 5, 6 dot dot dot, because the next number would be a 7 and then an 8, then a 9. So the set B that I'm doing in problem 2 is the same as the set A I did in my example, so I could use the same answers. So I could say it's a set of natural numbers greater than or equal to 4. I could say it's the set of natural numbers greater than 3 but not equal to 3, for the same reasons that worked before, because it's the same set. If I want to do something a little bit different, just to give you something kind of out of left field, I'll do that here in a second. So again, you only need one answer. Here are 2 such answers. Here would be another answer, a kind of funky answer in some sense, but it would be correct. I could say B is the set of all natural numbers other than 1, 2, and 3. And that still would mean the numbers 4, 5, 6, 7, 8, 9 all the way to infinity, because if I took the list of natural numbers, and the list of natural numbers, starts at 1, goes off to infinity, other than 1, 2, and 3 means not including 1, 2, and 3, and what's left if I take the set of natural numbers and I throw out the 1, 2, and 3 is the set B that I came up, that I had to write a description for. So there's 3 different ways to define set B. There's got to be 30 more that you could come up with that are maybe just bizarre but correct. So you should be able to stop the video, do problem 2, check my answer to problem 2, do problem 1, check my answer to problem 1 to see if it matches up with yours exactly. If it doesn't match up with yours exactly, at least try to, in your mind, know that your answer is correct, because there's definitely variability that's acceptable here. My set that I'm going to do here, problem 4, is probably harder to describe than problem 3 that you get to do. You probably have more flexibility with problem 3 than I do with problem 4, because problem 3 starts with the first natural number 1, and that gives you probably more freedom to use maybe some less thans in your description. For me, because my numbers, I have a beginning and an ending number, when I go to do a word description, I like to use the inclusive kind of thing that I did when I did problem 1. When I did the first example, we had the numbers between 1 and 5, and I had a solid first number and a solid last number. I kind of like to use this kind of word description when I have a first and the last number. If my list of my set of natural numbers doesn't have a beginning or an ending number, that's when I start using the greater thans or less thans. So when I do an answer to problem 4, I'm going to do something like mine's going to be E. E is a set of natural numbers between 5 and 10 inclusive. You certainly could do something just like that. So your answer for number 3 could look just like my answer for the first example. Also, for number 3, when you go to do it, you have some flexibility here. You could use a less than or equal to, kind of like I did for the extra answers in the first example. But I'm just going to write one example, one answer for this. So for number 4, I'm going to say set E, or I could say E is the set of natural numbers and then starting at 5, ending at 10, I'm going to use the words between when I have a beginning and an ending number. And I'm going to put that beginning and ending number, and then after it I'm going to put the word inclusive. And that would be completely fine. There's certainly other ways I could write an answer to problem 4, but I don't think there's anything that's significantly better. So I'll only write one answer, and again, when you do problem 3, you can use an answer just like I did for problem 4, or you can switch it up with a less than in your answer, or a less than or equal to if you prefer. So 5 and 6 don't have numbers in them, so using something in my answer that says anything about the set of natural numbers would seem silly. For my problem 6, I need to come up with words so that somebody, maybe not a mathematician, if they were reading my word description, would understand that the set has California, Oregon, and Washington. And when I wrote this, I was going to say the set of states in the United States that border the Pacific Ocean, but now I'm thinking Alaska also does. So I'm going to have to probably improve on my answer that I was going to write down here. And so I need to write something that describes California, Oregon, and Washington. And how about if I do something like this? B is the set. Now spelling comes up. Suck. Set of states south of Canada. I was going to use the word continental, but I don't think I could spell that. So states south of Canada, deleting Alaska, and making up for my inability to spell continental this morning, that border the Pacific Ocean. I think that's reasonable. At least I'm pretty sure that only includes California, Oregon, and Washington. So that would be a description. If you're more gifted with the English language than me, you probably can come up with a much better description than I have there. But completely, that's okay. This just as long as somebody that's reasonably educated could read my description and understand the elements that are in the set. And I think that works perfectly. For 5, either you have to know the story here or have kids or something, and when you peek at my answer, I mean, I'm assuming everybody knows that those are the 7 dwarfs, but maybe you don't. And if this, I wouldn't put something like 5 or 6 on a test that required being maybe a little more clever than I'd want you to be. All right. Oh. So 7 and 8 are different. I don't know why I have them paired together. 7 is definitely easier than 8. If you look at my answer for 7, well, you can maybe even argue that I'm not right because these are vowels, and I don't know about the sometimes why, but I didn't include that. For my answer, I need to come up with a description for 8. It certainly would be natural numbers might feel good in my answer because these are all natural numbers. And I was, I don't know that I was clever, but I created this list like this. For the 1, I did 1 to the 2nd power, which is 1. For the 4, I did 2 to the 2nd power. For the 9, it's 3 to the second power. The 16 is 4 to the second power. The 25 is 5 to the second power. The 36 is 6 to the second power. So the numbers in set T, these are called squares. So 1, 4, 9, 16, 25, and 36. The numbers in set T are called squares. Or maybe even perfect squares, but I'll just call them squares because that's probably more common. So I'm going to use the word squares in my answer, and maybe I'll use the word natural numbers again because these are certainly natural numbers. I'm going to say T is the set of natural numbers. Those are definitely natural numbers. And then I can't use an inclusive because an inclusive I need a beginning and an ending part. And probably a greater than or a less than probably wouldn't work so well because greater than and less than kind of includes every number greater or every number less than. So it wouldn't make so much sense to use a greater than or less than. So I'm just going to say that are squares. Because that's what those numbers are, they're squares. That would be a completely acceptable answer, at least in my mind, because I understand that that's what that set means. The thing is, sometimes when you write an answer that to you is correct in your mind, somebody else might have a slightly different definition of the words that you're using, and they might not produce exactly the same set. So I guess you have to have like a common vocabulary and a common understanding of what the words mean. If the words that you're using, you define them one way in your mind and somebody defines them another way in their mind, then they might produce a different set. But I think that's a reasonable answer, and I'm not going to get too picky on the test. If your answer seems reasonable, I'm going to let it go. All right, so that's the first group of homework problems. Now we're going to get to the lovely set builder notation in our second group of homework problems. So the second group of homework problems that's going to come after this short little discussion is going to ask us to write sets in set builder notation. And set builder notation is a real formal way to write a set. And mathematicians love it, and I'm not so sure why, but yet if you read higher level math books, you'll see set builder notation everywhere. And set builder notation has 3 parts contained inside set braces. So set braces, I can hardly draw them, but that's a set brace. Sometimes we call them curly brackets. So that's a set brace. So inside a set brace, the very first thing that's going to be written is some variable, a variable meaning usually a letter. And I'll use, for my example, for my set builder notation example, the first thing's going to come up with it, which is a variable. It's normally a variable is usually a letter. And I often use the letter X unless the problem kind of makes it so I need another letter makes sense. If no other letter makes sense, X feels really nice. After the letter, we either put a colon or a vertical bar. Mostly I put a vertical bar. And if I was reading this, what I have so far, the curly brackets I read as the words the set of. So I'm going to read this is the set of. That's the curly bracket part. And then X or all X, I'll say the set of all X, using the word all in front of the X. And this vertical bar, I usually say it's the word such that. So what I've written so far, a mathematician would glance at that and say, this is a set of all X such that, and so I have the set braces, I have the variable, I have the vertical bar separator, and then something after the vertical bar is going to describe the set. So there's going to be something here, and there's a lot of variability here. A logical predicate, these are either words or symbols that describe the set go here. So words or symbols or some sort of even notation that describes the set is going to go after the vertical bar separator. And this is where the creativity comes in. The work in creating set builder form is figuring out what to write after that vertical bar that's going to describe the set exactly. All right, so that's what set builder notation is. Usually when we write set builder notation, the set that we're describing has a name, and usually preceding the set builder notation, we write the set name and then an equal sign. And for a lot of our problems, the set name is going to be A. So I'll write the set A equals the set of all x such that it has the property of the logical predicate. All right, keep plugging along here. All right, so now I have some examples of set builder notation. When I read this right here, this says the set A equals the set of all x such that x is a natural number, comma, that comma I'm going to read as and x is less than 3. So this is the set of all x such that x is a natural number and x is less than 3. You'll notice that if you sneak down to the bottom of the page, and when I was writing this, I said, well, this is how I would read this. This is because there's some flexibility. So look at this. I said I would read this as this set A equals the set of all values for x. Now I just said all x. And then with the property that, I said such that. But this part I was consistent. X is a natural number and x is less than 3. So I was inconsistent with what I wrote, but that's not a bad thing because mathematicians aren't always consistent. And set builder notation, when you're reading set builder notation, the key in your reading is the stuff to the right of the logical predicate. This is what it has to be uniformly stated. X is a natural number and x is less than 3. Here, saying x, A is a set of all x, or A is a set of all values for x such that, or with the property that. Those are interchangeable. You'll notice that I wrote 2 ways to describe the same set A. They both represent the numbers 1 and 2. They're natural numbers less than 3, and natural numbers less than 3, if I wanted to write A in roster form, which we haven't got to, A is just the set 1 and 2, because these are natural numbers less than 3. Natural numbers are the numbers 1, 2, 3, 4, 5, and the ones less than 3 are 1 and 2. So both set A's that I've written about here are the set containing the numbers 1 and 2. The first set builder notation is a little more wordy than the second set builder notation. Notice in the second version, instead of saying x is a natural number in words, I use this symbol. Saying x is an element of the set of natural numbers is the same as saying x is a natural number. This is a more mathematically elegant way to say the same thing, but it's equivalently correct. So those are both correct. So when you're asked, if you're given a set and you're asked to write set builder notation, just like if you're given a set and you're asked to write a word description, there's multiple correct answers. And I have these little circles here. The set braces are the curly braces. The variable x means, when I write an x to the left of the vertical bar, it means x, can take on a variety of values, whether they're numbers or words. The vertical bar, sometimes I say such that. When I wrote this, I said with the property that, because mathematicians are consistently inconsistent sometimes. And then the comma means and. What do I have here? That's quite an involved description of the set, blah, blah, blah. Oh, so on the last problem, so when I wrote this stuff, I tried to write it so if you were reading without my lecture, that you can just read it and not watch the video, which I don't know how believable that is. But I took the this set and I read it literally, And reading it literally actually produces a word description of the set. This is definitely translating these symbols into words produces a word description of the set. A equals a set of all values of x with a property that x is a natural number and x is less than 3. That is a word description of a set that's equal to those sets, that's equal to the set that has the numbers 1 and 2. On the next page of this, which may not be on the next page for you, it's on the next page for me because I had to blow this up. If I didn't blow up my font, nobody could read it when I was writing it, when I was showing it. So there's definitely other ways. If I was asked for that set A to write a word description, I could just say A is a set of natural numbers that are less than 3, and that would have the same meaning. All right, so now I have another example. I'm going to write something in set builder notation. And the set that I want to write in set builder notation is the set containing the numbers 2, 3, 4, and 5. So again, I'm not going to use a word description because if I'm asked to write set builder notation, I've got to use the squiggly brackets. And when I start to write my set builder notation, I'll keep the name of the set the same, and I'll write an equal sign. And then to the right of the equal sign, I'm going to write my curly braces. I don't have a right end curly brace here, but I definitely should. And then the first thing that goes after the curly brace is a letter generally. And if I don't have a reason to write, if there's a reason to write a letter other than X, I'll mention it. But usually I write the letter X and then a vertical bar. So this is the part that's kind of standard for all set builder notation. Set builder notation, set name, equal signs, curly brackets, usually the letter X, and then a vertical bar. That part, there's no creativity there. You just take that. That's like a template that you can just stamp for any time you're asked to write something using set builder form. You can just throw that in. What I need to do is write something after this vertical bar that represents the numbers 2, 3, 4, 5, and so forth. And the numbers 2, 3, 4, 5, and so forth, they're all natural numbers, and they're greater than or equal to 2. So I'm going to have to write something after this vertical bar that tells the reader or somebody that's looking at this that the set A contains the natural numbers only, and its numbers 2 are bigger. So I'm going to, on the next page, write down probably a couple different ways to finish out the set builder notation that describes the set well enough. The first of the 4 ways that I decided, first of the 4 ways that I decided to finish up my set is I used words. I remember that set was the numbers. What was the numbers? 2, 3, 4, and it went on forever. So I said X is a set of natural numbers. That means I'm throwing out negative numbers, I'm throwing out fractions, I'm throwing out decimals. And then more than being a natural number, because it's natural numbers not including 1, I said a natural number greater than 1. Greater than 1 doesn't include the 1, it includes any number bigger than 1. So writing this as a set builder form definition for set A, somebody would look at this, they read this, the set of all X with the property that X is a natural number, meaning it can't be negative numbers, nor decimals, nor fractions. And it's greater than 1, meaning it doesn't include the 1, but includes everything bigger than 1 that's a natural number. That would be completely fine. Another way to do this, again, is more the wordy way. Same beginning, X is a natural number, and then after X is a natural number, after the and, instead of greater than 1, I wrote greater than or equal to 2. Those are exactly the same when we're dealing with natural numbers. Greater than 1 doesn't include the 1, starts with the 2. Greater than or equal to 2 starts with 2 and goes on. The next 2 are kind of symbolic forms of the first 2. So the third and the fourth one say the same thing exactly. One has symbols, the other has words. And the first and the fourth one say the same thing. So 3, A is a set of all X with the property that X is a natural number. So this little symbol right there, X is an element of N, it means X is a natural number, and it's probably a nicer way to write it. I use the comma for the and then there's the symbol for X is greater than or equal to 2. So these 2, the third and the fourth description on this page, say exactly the same thing. The third one is probably way nicer to write than the fourth one. The bottom one and the top one say exactly the same thing. The beginning is the same, the set of all x, a equals the set of all x such that, and then instead of writing the words x as a natural number, I could use the symbol for x as an element of n, which means x is a natural number. Instead of using the word and, I use the comma, and instead of using the words x is greater than 1, I use the symbol for x is greater than 1. So those are really equal to each other, but the short, slick notation is probably preferred for mathematicians just because it takes less writing and it says the same thing. There are definitely other ways to write this that are equivalently correct. I just can't think of them right now, but you might have, if you were working ahead, came up with something that was different but correct. Oh, all right. So I'm not ending these examples, so I feel like I already did enough examples, but let me do one more. So here I want to write this set A of natural numbers between 3 and 7 exclusive. Oh, the word exclusive isn't something I've used so far, at least not in this section. So exclusive, when I say between 3 and 7 and I say natural numbers, well, the natural numbers between 3 and 7 inclusive would include the 3 and they would include the 7. But exclusive means you don't include the n numbers. So this set A, its word description to me means the numbers 4, 5, and 6. It's natural numbers, so I'm not counting the fractions or the decimals between 3 and 7. And it's exclusive, so I'm only counting the numbers between 3 and 7, and I'm not counting the 7, nor the 3. All right, so now I'm going to do my set builder notation. I called it set A, so I'm going to write set A in my set builder notation. I'm going to write A equals the set of all x with the property that, and then the whole work is to figure out how to get something to the right of this vertical bar that represents the numbers 4, 5, and 6. Probably the nicest way to write this when a set is a range of numbers, you usually can write that range with inequality signs. And when x is between two numbers, I generally, the nice slick way to write it is to write the x between those two numbers. So on the next page, somewheres in my word description or in my set builder notation, I'm going to have x between the 4 and the 6 because x is between 4 and 6. And anytime I put a variable between two letters, if mathematically I want to say the number that the letter represents is between those two numbers, you put less than signs. This right here would say x is less than 6, and this would say 4 is less than x. So it says 4 is less than x and x is less than 6. This would describe x being between 4 and 6, but it wouldn't include the 4 or the 6 because less thans don't include the endpoints. If I popped an or equal to on these, would say 4 is less than or equal to x, so x can be 4, and x is less than or equal to 6. So this is something that's going to go in my set builder notation when I flip on to the next page. So generally, if I'm asked to write set builder notation and x is between two numbers, I start off by writing the x between those two numbers, and I only ever put less than symbols. If one of these symbols was a greater than, you'd probably be writing something that's either wrong or right but odd to look at. So if we want to describe x being between two numbers, we put the x between those two numbers, we put less thans between each of the numbers and the x's, and we put or equal to if we want x to equal that number. We don't have the or equal to if x isn't allowed to equal that number. All right, so now I am going to write my answers two different ways, and I'm writing it in a slightly slick way. So I know x needs to be A needs to be the set 4, 5, and 6, so it's in natural numbers. So I'm going to immediately, when I'm writing my set builder form, I start off by saying x is a natural number. I could have, instead of using the symbol x as an element of n, I could say x is a natural number. That would be equivalently correct. So these symbols are interchangeable. So if you tried to make an answer, and instead of using the shorthand x as an element of natural numbers, you use the word x as a natural number, that would be fine. Similarly, my comma and the word and are interchangeable. So in my answer, I have a comma, not the word and. So these parts, there's a little flexibility. And then right after this, x has to be, the number has to be between 4 and 6. There's lots of ways to do it. Notice in this one, I said x is a natural number between 3 and 7, but it doesn't include the 3 and 7. And natural numbers between 3 and 7, not including the 3 and 7, that's the 4, 5, and 6. So when I don't have the or equal to signs, x is between those numbers, but it doesn't include the first, it doesn't include the last number. So this represents the numbers 4, 5, and 6. The second way I described this, when I did the less than signs, I put equals with them. So x is between 4 and 6, and it equals 4, it's allowed to equal 4, and it's allowed to equal 6, and it's a natural number. Even another way to write this, I could say a equals the set of all x such that x is a natural number, and I can do x is between 3 and 6. It's bigger than 3. 3 is less than x, which means x is bigger than 3. It can't equal 3, so I'm discarding the 3 and starting at 4, but it's allowed to equal to 6. So this would be a kind of a combination of these. So if you have a less than without an equal, it can't equal the edge number. A less than with an equal sign, it equals the edge number. Each one of these three descriptions represents the set that has the numbers 4, 5, and 6 in it. Finally to the homework. So 9 and 10 have the same sort of feel to it. And nicely, they're natural number problems. So I'm going to do 10 with the idea you could use my 10 to get 9. And in this problem, I'm not going to have to write x between two numbers because there's not a beginning and ending number. So when I do my problem 10, or when you do your problem 9, you'll probably start out using your name of your set. For 9, you're going to do D. For 10, I'm going to do A. And I'm going to write my set builder notation. So the beginning of my set builder notation is kind of stuck. So I'm writing A is a set of all x with the property that, and I have to say x is a natural number because these are natural numbers. If I don't make that comment, that would allow decimals and fractions. So, and the slick way to write x as a natural number is using that notation. But I could have said, right here, I could have said x is a natural number instead of that symbol, and it'd be completely fine. And then I'm going to write a comma, but instead of the comma, I could write the word and we'll read those the same way. And then after that comma is the key. I need to write something so it's the natural numbers that are 3 or larger. And for me, I'm going to use a greater than symbol because those are numbers 3 and bigger. And if I did greater than or equal to 3, that would include the 3. Another way to write the answer to problem 10, I could say A equals the set of x such that x is a natural number with words or the symbol, comma or the word and then I can say x is greater than 2. And then x is greater than 2 wouldn't count 2, would count the first natural number bigger than 2, which is 3. So both of these would be okay. When you go to do an answer for number 9, your answer could look a heck of a lot like my answer. And again, there's multiple correct answers, which sometimes make these problems, not my favorite. Now there's 11 and 12. And for both 11 and 12, because x is, there's a range of numbers, there's a first and the last number, I'd probably, when I go to write my set builder notation, write the x between those two numbers. So when I go to do number 12, or when you go to do number 11, I'm going to write b equals, you're going to write 8 equals, use the set builder form, and then after the set builder form, I'm going to put my x between the first and the last number, and if I want those numbers to be included, I put or equal to signs. And always when I write x between two numbers, I write less than signs. So this would be a perfectly correct way to do part B. And no, it's not correct. It's perfectly incorrect because this, and this could be something you'd write on a test, that would be wrong because this would count a number like 1.5 or 1.75. This is not correct enough because that doesn't exclude fractions from being in my answer. So let me improve upon the mistake I just made because I haven't said that x is a natural number. And if I don't include the thing that says x is a natural number, that means you could have decimals. So I could have like 5.75 in this list, and my list of numbers doesn't have decimals. So that's no good. Let me improve upon it. Now it's going to be correct. And as long as this after the vertical bar translates to this set, which is written in roster form, you have a correct answer. There's got to be other correct things that I can write to the right of the vertical bar here, but not many much more correct things. But if I didn't say x is a natural number, my answer is totally wrong, or wrong enough to lose decent points on a test. Oh, okay, so I did a word description in 13 and 14. So I'm going to do 14, and so I'm going to write P, because my set name is P, and then an equal sign, and then my set builder notation, the set braces, the letter X in a vertical bar. And for me, and for you, we have X between two numbers, inclusive, meaning including the endpoints, and X is a natural number. So I'm going to start off by saying X is a natural number, comma for the word and then I'm going to put the X between the two numbers that are mentioned. And anytime X is between a range of numbers, I only ever put less than signs between X's and the numbers. If it includes the number, I put an or equal to. If it doesn't include the number, I don't put an or equal to number. Because of the word inclusive, my X is allowed to equal the 4 and it's allowed to equal the 9. So I had to write my answer just like that. There are other ways to write the answer. Another way to write this answer, and it's no real reason to write it this way, but this would still stand for the numbers between 4 and 9, the natural numbers between 4 and 9, because when I don't have the or equal sign, it will start at the next higher natural number. So it's not including the 3, it includes the natural number bigger than the first natural number bigger than 3, which is 4, doesn't include the 10, includes the first natural number less than 10, which is 9. But this one just makes sense to do. I mean, that's just, the problem reads like that. You might as well do it like that. 15 and 16, I see the word exclusive. And when I see the word exclusive that doesn't include the endpoints, I'm going to use the not the or equal to. So when I go to do 16, I'm going to write P equals the set of all X such that set braces. It's a set of natural numbers, so I'm going to write X as an element of N for X as a natural number, comma for the and I can certainly put the X between the 4 and the 9, and always when I write a letter between two numbers, I only put less than signs in. And in this case, I don't want the X to equal 4 and I don't want the X to equal 9 because of the word exclusive. It doesn't include the 4 and it doesn't include the 9. The numbers that this set includes are 5, 6, 7, and 8. And that would be a perfect representation for it. Another way to do it, again, this is a second correct answer, and you don't need two correct answers. One is enough, but you could do this as well, because both of these would represent the natural numbers between 5, 6, 7, and 8. Those are both less than or equal to signs in case the second one doesn't look like a less than or equal to. Hopefully that gives you inspiration to do 15. We're getting closer to the end of this, kinda, and we're in the last kind of way to describe a set, which is in roster form. And a roster form for me is the easiest. A roster form is just listing all the elements in the set, and there's a much less creativity when you're listing the elements of a set than word descriptions and set builder notation. There's usually multiple correct answers. Roster form, it's kind of hard to get multiple correct answers. So roster form is just listing in set braces the elements of the set. So if in this example, if I want to write the set A of the natural numbers between 3 and 7 exclusive, well, natural numbers, again, they don't have the decimals, they don't have the fractions. If I'm saying between 3 and 7 exclusive, then I'm not including the 3 and I'm not including the 7. So the natural numbers between 3 and 7 inclusive would include the 3 and the 7. The natural numbers between 3 and 7 exclusive don't include the 3 and the 7. So this set A is just talking about the set that contains the numbers 4, 5, and 6. To write this in roster form, I'm going to write the name, which is set A, an equal sign, and then the set braces, and then inside the set braces the elements that are in the set. And so A is going to have the numbers 4, 5, and 6 in it. So roster form is just a matter of figuring out the elements that make up the set and write those elements in set braces. It wouldn't actually have been wrong if I would have said A is the set 5, 6, and 4. That's equal. Sets are equal if they have the same elements, even if the elements aren't written in the same order. So if for whatever reason you wanted to write the elements in a different order, there wouldn't be anything wrong with that. Here's another example. Write the set in roster form. A is a set of natural numbers greater than 5. So numbers greater than 5 don't include the 5. So natural numbers greater than 5, natural numbers go on forever when they're greater than, so I can't write all the natural numbers greater than 5. And natural numbers greater than 5 don't include the 5. They include the first natural number bigger than 5, which is 6. So if it would have said greater than or equal to 5, when I wrote the roster form, 5 would be in my answer. But if it says specifically greater than and doesn't have their equal to, it doesn't include the 5, it includes the first natural number bigger than 5, which is 6. So when I go to write my answer, 5 can't be part of my answer. It's the natural numbers bigger than 5, which is 6, 7, 8. And then eventually I'm going to stop writing my natural numbers. For me, 3 is enough to establish a pattern. But if you wanted to, you could write a heck of a lot more numbers after the 6 if you had the desire. But eventually, regardless of how many numbers you write, eventually you're going to have to default to writing ... because I can't write up to infinity and I'm just going to run out of paper or run out of ink. So for me, 3 numbers, if in an infinite list, 3 numbers is enough to establish a pattern for me, especially a pattern as simple as that. So these would both be correct ways to write the A. It would be completely wrong, or it would be wrong if I had the 5 in the answer, because it doesn't have an or equal to with the word greater than, which means it doesn't include the number that's given in the description. Ooh. So, another one that I need to figure out the elements. When I look at this set D, it only has natural numbers, so I'm not worried about decimals, I'm not worried about fractions. It's between the numbers 4 and 8, because when I write a letter between two numbers with less than signs, that letter that represents numbers between those two numbers, in this case natural numbers between 4 and 8. And in this problem, I need to include the 4 because the 4 has an or equal to. So when I go to write the list, I'm going to include the 4, but I'm not going to include the 8. I'm going to exclude the 8. So when we have set builder notation, if your set's going to be a range of numbers, you'd always put the letter between the two numbers, the lower and the highest number, lowest number, less than sign, letter, less than sign, highest number. So this is the proper form to describe X as the numbers between 4 and 8. And then I have to figure out which ones I'm excluding and which ones I'm including. So I'm including the natural number 4. I'm including 5, 6, and 7 because they're between 4 and 8. And I'm not including the 8 because the 8 doesn't have an or equal to. So set D is going to be the set 4, 5, 6, and 7. Oh, another. This one's a little bit trickier. And when I blew up the font, it didn't really look so nice. So set B is a set of all x such that x is a solution to x plus 1 equals to 9. This is the first algebra we're going to do all semester. We're not going to do a lot of algebra this semester. So set A is described as a set of solutions. Notice I didn't even say x is a natural number. X is the solution to this. So what I need to do is I need to solve x plus 1 equal to 9 to figure out in roster form what this set contains. And I just take this problem, I'll minus 1 from both sides, and I'll get x equal to 8. So this set B only has the element 8 in it. So I'll just say B is the set that contains 8. Alright, so now we're ready for the homework. So each of the problems between 17 and 32, which I think is the rest of the section, gives us a set and asks us to write it in roster form. Some of the definitions of the set will be in word descriptions, some will be in set builder notation. So we need to be able to go seamlessly between set builder notation, word description, and roster form. And for me, I like roster form the best. So these should be the easiest problems because roster form, there isn't a lot of flexibility in terms of how you write your answer. So I'm going to do problem 18, problem 17 staring at you right there. So after I do 18, you should be able to do 17. Roster form, I'm going to start off by writing the name of the set. In problem 18, the set is A, so I'm going to write an A, then an equal sign. And then roster form also has the set braces. After, or inside the set braces, I need to write the elements of the sets. And it says natural numbers, but before it says even natural numbers. And even natural numbers are like numbers 2, 4, 6, 8, 10, 12. Those are even natural numbers. Now it says between 5 and 10 inclusive. So I want the natural numbers, I'd include the 5 and the 10 if they were in the list. So if I look at my list of even natural numbers and I want to be between 5 and 10, those are the numbers between 5 and 10 because 4 is not between 5 and 10, 12 is not between 5 and 10. So those are the natural numbers that are described, those are between 5 and 10. Now it says inclusive, so I want to include any number that's, I'd include the 5 if it was one of the natural numbers, even natural numbers between 5 and 10, and I'd include the 10. Here I'm just going to write 6, 8, and 10 in my answer. I'm not going to write 5 in my answer because 5 isn't in the list of even natural numbers. So to be in set A, you have to first be an even natural number, so 2, 4, 6, 8, 10, and 12, and then you have to be between 5 and 10 inclusive, and those are 6, 8, and 10. So my answer for this is going to be 6, 8, and 10. For your problem 17, I didn't sneak the word even in there, so your problem's a little bit different, but hopefully you can work through it. Your problem 19 has the word even in it. My problem 20 has the word odd in it. So the first thing I see, A is a set of odd natural numbers. Odd natural numbers are like 1, 3, 5, 7, 9, 11, ... And again, when I have an infinite list, at some point I've got to put a ... to mean the pattern continues. So for roster notation, I'm going to write set A equals set braces, and then I want odd natural numbers greater than or equal to 5. So or equal to means it includes the 5. And so this is the numbers that I want to describe in my set A. And in my roster form, I'm going to need the ... because this is an infinite list and I can't write infinitely many numbers. So I'm just going to write 3 numbers, 5, 7, 9, and then ... I did 4 dots. 3 is probably more correct, but 4 is okay. And this to me would mean 5, 7, 9, 11, and so forth. So notice I didn't say x is a natural number because this pattern just implies that the next number is 11, 13, and 15. So it's implied that my set is natural numbers. I don't need in roster form to use the x as a natural number. '21 and 22 kind of feel like the same problem. Hopefully they look a lot the same. So I'm going to write for roster form for problem 22, A equals, I'm not going to write, the vertical bar for set. If it was set builder notation, I would have to do more. But I'm not doing set builder notation. But if it was set builder notation, I would have that junk. But not doing that here, I'm just writing the list. So I want natural numbers greater than 5. Well, natural numbers greater than 5 don't include the 5. They include the first number that's a natural number that's bigger than 5. If it said greater than or equal to, when I write my roster form, I'd include the 5, but it doesn't say or equal to, so I'm not including the 5. I'm including the first natural number bigger than 5, which is 6. And it's an infinite list, so I need a dot, dot, dot. And the minimum you can write is 3 numbers to establish the pattern. That would be fine. If you wrote 6, 7, 8, 9, 10, dot, 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 that would be okay as well. Oh, 23 and 24 fit together. So 24 wants me to do the set of natural numbers less than 0. Well, here's the set of natural numbers. Here's 0. There's no natural numbers less than 0. So this is a trick question, as 23 is a trick question. So there's nothing to put inside my set. What I'd put inside my set builder notation is any natural number that's less than 0. Since there's no natural numbers less than 0, it would be fine just to do that, saying this is a set with no elements. A is an empty set. There's no element inside A. Another way to write my answer for this, the other notation for empty set, is that. So when there's no elements in a set, you can just write the set braces with nothing inside of them. That has the same meaning as a 0 with a line through it. So these two mean each other. A set with no elements is the same as the empty set. Some algebra. So 25 and 26 work the same way. I do 26, you should be able to do 25. Ultimately, I'm going to say B equals, and I'm going to put the elements of B, and the elements of B are the solutions to the x minus 3 equal 5 equation. Easy enough for me to solve. I'm going to solve that equation off to the side here, and I'm going to get x equal to 8. So my answer for 26 inside my set braces is just going to be the number 8. Getting close to the end. And 27 and 28 feel like they should work the same way. Again, when I blew the font up, this kind of messed this up, so I want m as a natural number that is less than or equal to 3. So natural numbers, again, natural numbers are 1, 2, 3, 4, 5. I want less than or equal to 3, so I'm not going to count anything bigger than 3. And because it has the or equal to, I'm going to count the 3. So my answer for number C, or question 28, the set C is a set of natural numbers less than or equal to 3. There's the natural numbers. 2 and 1 are less than 3, and then 3 is equal to 3. So it counts the 3 because it has the or equal to. If it just had m is less than 3, like the problem you're getting in problem 27, your answer is not going to include the 3, because less than without the equal to sign doesn't include the number, includes the first natural number less than it. Two more problems. 29 and 30 I put together because they work the same way. So 29, it refers to the numbers between 2 and 5, and the number 30 refers to the numbers between 2 and 5. But when I go to write my answer, I have to figure out which numbers I'm including and which I'm not including. For 30, I'm going to include the 2 because of the or equal to, but I'm going to exclude the 5 because I don't have the or equal to with the 5. So my answer to problem 30, the roster form for D, is going to be the set that contains just the numbers 2, 3, and 4. So I have to be real careful with less than and less than or equal to signs. And anytime there's set builder notation, if you have a range of numbers, you always put the letter between the two numbers with less than signs, or less than or equal to signs if you want to include the edge, the end point. All right, last one. 31 and 32, hopefully you will have finished all the odd problems by the time you get done watching this video. So again, I have the letter M written between two numbers, And I'm not including the 3 because there's no equal to with the inequality with the 3. I'm not including the 7 because there's no or equal to with the inequality sign with the 7. These are strictly less thans, which means it doesn't include the number that's described. It includes the next natural number. So for 32, D is going to be the numbers 4, 5, and 6. All right, so that's everything I wanted to say in section 1.2. Hopefully it didn't feel awful. I'm not sure it was like my most awesome lecture ever, but hopefully I got the point across and you could do the homework.